We have Louis Mosley, head of Palantir Technologies UK. And Louis, your company is a specialist at data and technology and providing security in many different ways. How are you thinking about secure delivery of energy and how to maximize the use of data and to deal with the kind of difficulties of getting energy to consumers, of reformatting your mix so that you're dealing without Russian oil and gas?
Well, I think the point that you made about the degree to which the world is changing and changing rapidly is in a sense the key point. We've entered an age of increasing dislocation and disorder. The crisis in Ukraine follows COVID. I think we've had 30 or 40 years of actually a focus on convergence and harmonization. That was globalization, the convergence of standards, the harmonization of economic models. And we're now entering a world of divergence and unpredictability. And I think that shifts the emphasis from incremental marginal efficiency to actually resilience. And resilience is about adaptability and agility. And from a tech and data point of view, that looks like many of the systems on which the businesses that are represented here in this room run will have been developed, the logic will have been formed perhaps 20 or 30 years ago. And it's very, very hard to change that logic, the way you run your supply chain, for example. And then all of a sudden, overnight, the energy mix has to shift. Or during COVID, we saw workers have to suddenly stay at home. And how do then businesses adapt that rapidly? How do they start to develop that agility, that adaptability? And that is partly a technical problem. It's a data problem.
Yeah.
If you have that granular visibility into every aspect of your business, that single pane of glass, then your ability to rapidly re-optimize your supply chain, your inputs, whatever it might be, is the game changer.
Yeah.
And I think that's where we're seeing the biggest impact of our work and support for customers.
How urgently is that conversation happening? Have you been surprised at the urgency, or are you sort of just still waiting for sort of some of that momentum to happen?
No, I think every single customer we have has some version of this challenge. Clearly that we work with a number of the large oil and gas, the majors, on the production side, and as you mentioned, the impetus then to suddenly emphasize increasing production. For example, BP we've worked with for a number of years, and they use our software to optimize production across all their platforms and assets around the world. And when we first started working with them 6-7 years ago, the oil price was $100 or more a barrel. In those days, it was all about getting as much out of the ground as quickly as you could. Then the price tanked, and all of a sudden it became about saving costs, and again, enabling them to make that rapid transition to a completely different emphasis. And then we're back to maximizing production. But at some point, as you said, James, then the emissions will re-enter the equation. And of course, it is an equation in that sense. So how do you trade off maximizing production with ensuring safety and then increasingly your carbon emissions?
Louis, you have some experience of working with energy majors in terms of, these are companies with huge scientific hinterland, with huge R&D. How can you work with them as a data and technology specialist to help them achieve getting them into this energy transition equation?
How do you enable that cooperation? Be it the public-private cooperation or the intra-industry cooperation. And a large component of that is data. If you take, for example, Scope 3 emissions, which I'm sure is a topic that we'll get onto, that is a very, very large portion. In some cases, for some businesses, it's 90+% of their emissions. And while it works to do the aggregate and the estimated, the sort of the macro picture that you described, James, if you get down to the granular level of an individual business, and then down to the decisions that need to be made at the coalface, as it were, to start to influence this, you need that granular data, you need that granular information, and understanding those trade-offs between taking path A versus path B. And then layering on top of that, you need to start sharing that data between different organizations. And in the case of Scope 3 with a supply chain, you might have organizations within that supply chain that don't fully trust each other, or maybe in competitive dynamics. And therefore, the sharing of that information can be very fraught. And so there's a data governance problem that sits on top of the foundational technical problem of how do you make that data accessible in real time and accurate and so forth. That's something that we have, I mean, both those problems are areas that our software has been used to address for a long time. In some senses, in fact, our origins in national security, that was, the data governance was the first problem we helped that sector solve. How would national security intelligence agencies share information with one another in a very low trust environment where actually you might be able to see one subset slice of some information but not the full picture because you have a common threat and an interest in collaboration.
And talk to us, there's obviously a lot that can be done with technology beyond creating wind farms or better solar plants. Can you just help us understand the scope of where we are in sequestering carbon from the current system, in creating the new system? And then where are there additional concerns that should be looked at? And I'm thinking here, supply chains for renewable technology, the cobalt, the lithium, how those supply chains are governed and what the sort of whole sort of chain looks like.
Well, I mean, I think that's clearly is a geopolitical question. The kinds of inputs that are going to be necessary to drive that transformation, rare metals, etc., are found in different parts of the world to what perhaps the traditional energy mix was derived from, and countries will now start to need and are starting to ensure that they have that security of supply, and that is shifting the geopolitical dynamic. It's something that then every company is going to have to start to think about in terms of their own supply chain. Clearly governments are thinking very hard about it, but it has that ripple effect into every corner. And I think as time progresses, it's going to become a more and more significant issue. We need to increase the velocity of experimentation and the rate of learning in order to drive that adaptation. And I don't think anybody has the answers yet. That's why we need to try, and we need to increase the velocity of what we're trying. And that's about learning, and that's about feedback loops. We need to experiment and then learn and experiment again. And I think it kind of comes back to this point of, a world that we were in for 30, 40 years where we saw we thought we were seeing the convergence of these economic models, and indeed of political models, that a lot of these fundamental questions had been answered. That's turning out to run out of road. And so we need to revert to a world in which we are embracing that change. And I mean, I can give you one just very specific example going back to COVID. The National Health Service, the NHS, the healthcare system here in the UK, perhaps not renowned for being the most adaptable and agile of organisations, ran in effect the first mass vaccination program of any large country and ended up running the fastest and one of the most efficient. And what was fascinating, we had a ringside seat because it ran on our software, was to see it was actually about the mindset. It was that they approached it as no one has ever run a vaccination program of this scale. We don't know how to do it. So we're going to have to approach it with an open mind. Now that starts with, we need real-time accurate data. We need to see minute by minute, hour by hour, jabs going into arms all over the country. That will allow us to discern those inequalities of uptake as they're emerging. Some communities seem to be embracing the vaccine, others are not. The experts can then start to design interventions for those specific communities. You start to see in real time, are those interventions working? Are we starting to see an increase in uptake? If they're not, try another intervention. If they are, brilliant, scale that to all those other pockets of those communities around the country. And it was that learning system, it was that ability to use data, create the feedback loop that was critical to getting there. And I think, the way in not all aspects of the COVID response, but I think there are those pockets of the COVID response and the discovery of a vaccine and the rollout of the vaccine being, two great examples why I think we should be optimistic about our ability to manage these, in some senses, even bigger and more challenging disruptions. I mean, if you take BP, they have over 3 million sensors across what they used to call their upstream business, so the oil platforms. Some of those are very, very simple sensors. The inlet pressure on a valve, it's a single data point per second. Some of them are acoustic sensors with 10,000 data points per second. How do you marry 3 million of those in real time. How do you then layer on the dozens, in some cases hundreds of models that may have been defined 30, 40 years ago that represent the activity of this aspect of the platform? Chain those models together to give you, in the jargon, your digital twin, your virtual representation of the platform that then allows you to run scenarios and say, well, if we were to do this, we will get that. If we want to optimize for carbon emissions and the trade-off then with production or with safety, what is the answer? And I think business is going to need those capabilities in order to explain to equity investors that they have the handle on those trade-offs that's going to be required to unhook the very significant investment that's required.